There's two forms of equations for parabolas. One of them starts with y equals. And this is going to give us a vertical parabola. It's either going to be upward in the positive or it's going to be downward. So it's going to either have an upward curve or it's going to have a downward curve. And it depends on whether it's going to be a positive a or a negative a. The other equation starts with x equals. And this will be a horizontal parabola. We're either going to have a parabola that opens in the positive direction or a parabola that opens in the negative direction. Regardless of which type of equation we have, the vertex is going to be the point h, k. Notice that the h is with the x and the k is with the y. It's very important. The a is what helps us to define whether or not the opening is whether it's an upward, so we have an upward or a downward, or a open to the left, a negative, or open to the right, a positive, or whether or not it's wide or skinny or any of those kind of things. So the a has a lot to do with skinny or wide or the opening being positive or negative direction. So there's two new parts that we're learning about in a parabola, and one of them is the focus and the other is the directrix. Here's just a graph where we can see that we have a parabola, and there's this point right here inside the parabola and this line outside of the parabola. The point is the focus and the line is the directrix. There's also that vertex that we know, and we have the line of symmetry that we have talked about in the past. So, to find our focus and directrix, we're going to need this number p. And we've got both of these different types of parabolas shown here, an upward, a positive parabola that starts off with a y equals, and this is also a positive parabola, the a would be positive, but this would be an x equals because it opens on the positive x-axis here. We have the focus, we have the directrix, we have the vertex, we have the line of symmetry going on here. And if you notice, there's a distance between the vertex and the focus, some distance here, and there's a distance from the vertex to this directrix, some little tiny distance right in here. If we look over here at this one, there's a distance between the focus and the vertex, and down below there's a distance between the directrix and the vertex. Well, those distances, this distance here and distance here, the distance that we have here between the vertex and the focus, and this distance between the directrix and the vertex, those are all this distance p, and it depends on the parabola what that is. So we need an equation for that p, and the equation is p equals 1 over 4a. And the a is the a that's in the equations that we've been talking about. So for an upward positive parabola, the p would be added to the k. For a downward parabola, the p would be subtracted from the k. From an opening to the right, a positive, the parabola that is an x equals parabola, it's added to the h, the x. This is an x equals parabola, and it's subtracted from the h. Notice that these two are x equals, and we've added and subtracted from the x in the vertex. In these two parabolas, these are parabolas that started off with y equals, and we added and subtracted it from the y in the vertex. But what about the directrix? Well, if we get rid of all that, we're going to have the directrix be y equals, and we're going to now add it to the other thing, the k, or to the k in this particular one. It's k minus p, and here it's k plus p. Again, these are y equals parabolas. Our directrix is y equals, and we add and subtract the p. Depending on whether it's a positive parabola, we subtract the p. If it's a negative parabola, we add the p. Over here, these are x equals parabolas. The equation for them would say x equals a times the quantity y minus k, quantity squared plus p, and plus h. Well, here the directrix is going to be x equals h plus p and x equals h minus p. Again, it depends on the opening, whether it's up or down or left or right, what we add or subtract the p to. Let's look at some examples. So in example 1, we have this equation that is that of a parabola. We know it's a parabola because while we have an x squared, we don't have a y squared anywhere in this equation. So I know this is going to be an equation of a parabola. What I need to do is I need to write this in vertex form. So I'm going to be completing the square. Notice that I first separated it so that I have the y term all by itself on the left, the x terms and the number on the right. I've left a gap where I'm going to complete the square. I'm going to add -2 squared and subtract -2 squared so that I've added it and subtracted it, which is 0. But that's a complete square, so it's going to be 4y equals the quantity x minus 2 quantity squared plus 12. Divide everything by 4, and we now have the vertex form of the equation for the parabola. This is a y equals parabola. My a is positive. It's 1/4, so it's going to be wide, and it's also going to be in the positive upward direction. The vertex, the hk, is 2, 3. The line of symmetry is x equals 2. For the focus and the directrix, I need to find the p, and p equals 4 divided by a. My a is 1/4. Well, 4 times 1/4 is 1. 1 over 1 is just 1. So my p that I'm going to be adding and subtracting is 1. So for the focus, I'm going to have -2 comma 3 plus 1, because I'm doing the k plus the p. And so I have my focus. And for my I'll write that down. And then for my directrix, I've got y equals 3 minus 1, which means y equals 2. And now I'm ready to graph it. And so I do my points, my line of symmetry, I graph my focus, I graph my directrix, and I'm done with the entire problem because we've graphed it. You can stop this and analyze this on your own. We're going to move on to the next example. Example 2. Again, it's written out in expanded form. We need to complete the square and get it into vertex form. So I get the x's on the left and the y's along with the number over on the right, leaving a gap to complete the square. I'm going to add 2 squared and subtract 2 squared, both add it and subtract it. I have the complete square, and 20 minus 4 is 16. Divide both sides, divide everything by 8, and I now have the parabola in vertex form, so I can find my hk. So I'm noticing that since this is an x equals parabola and it's positive, it's open to the right, the positive direction. So this is good to remember that this is what I'm going to get for my parabola. The vertex is 2 comma -2. And you might be saying, why? Well, remember that your h and k, which determine the vertex, because this is an x equals parabola, my h is here this time, and the k is the opposite of what I see in here. So instead of +2, I know that it's going to be -2. So I've got 2, -2. So now the next step is to find the line of symmetry, which is going to be y equals. In this case, because this is a parabola that's open in this direction, the line of symmetry will be a y equals line. And we know that it's y equals -2. We get that from the vertex. We need to find the focus and the directrix, and to do so we need to find our p. And remember, p is 1 over 4a. In this case, a is 1/8. So 4 times 1/8 is 1/2, but 1 divided by 1/2 is the same thing as 2. So in this case, I'm going to add it to my x. I'm going to do h plus p, comma k, and that will be my focus. So 4 comma -2. And I'm going to say x equals h minus p for my directrix, which is going to be 2 minus 2. I'm going to get 0. So it's time to graph it. I graph my points, my line of symmetry, my focus, my directrix, which is x equals 0, that's the x-axis, or the y-axis there. So we have finished this problem, and those are the two examples and a little bit of tutorial on parabolas with focus and directrix.